Alright, so section 10.7 is on factoring special products. And this is the part of the factoring map far left, under 2 terms, and then under 3 terms, where we're looking for trinomial squares. So the first thing we want to do is go to that factoring map and take a look at factoring a difference of squares or a trinomial square. And these you should be familiar with already. So here we have a 3-term polynomial. Now, quite honestly, if I was factoring this and I saw this, I would go through the factoring map. Is there a common factor? No. Count terms, 3. Choose a method. And I would choose trial and error. But I'm using this example to show you how to pick out a trinomial square. And the way you do that is you take a look at the first term. Is the first term completely a perfect square? In this case, x squared is a perfect square. So that's the first part. Is the last term a perfect square? Well, 16 is a perfect square. Is the middle term 2 times the first term times the last term? In this case it is, so this is going to factor into a plus b quantity squared, because we have a squared plus 2ab plus b squared. Here we have another 2-term polynomial. Is there a common factor? No. Count terms, 2. Is it a difference of squares? Well, if the first term is a perfect square and the last term is a perfect square, then and there's a minus sign in between, it's a difference of squares. Obviously, we can't have a plus sign in between. That'd be a sum of squares, and a sum of squares won't factor. When we're factoring this, all we do is we take a look at the first term, 9x squared, and we take the square root of that. The square root of 9x squared is 3x. The square root of the second term is 4. So we have 3x plus 4 times 3x minus 4, or a plus b times a minus b. And that's why you've memorized that part of the factoring map.